Hey everyone, thanks for coming. My name's Graham, and Carl, Vince, and I are excited to talk to you about our project Pilot, which is an open source, multi-cloud framework for provisioning an internal PaaS with a workflow-agnostic build, deploy, and release pipeline. Today, we'll start out with exploring the problem domain that Pilot is operating within. Then, we'll demo Pilot and discuss the underlying architecture. Afterwards, we'll cover some of the decisions we made when designing it, followed by a couple implementation challenges. We'll also cover some features we'd like to implement in the future. Now, I'd like to introduce you to ACME. ACME is a small company in the private airline industry. Many small airlines have been using their application, but business is growing faster than their monolithic infrastructure can keep up with. Let's take a look at their application. With a monolithic application, all business logic is handled within the same code base, and in ACME's case, on a bare metal server that they own. This has been ACME's tried and true approach for a while now. However, this infrastructure has limits. With a single server, they're limited by physical bottlenecks like the server's memory and networking capabilities. Because of this, ACME's CTO has been working on their digital transformation plans. And generally, the term digital transformation means improving business processes by modernizing the company's technology and operations. As part of their digital transformation, the CTO has informed the development team of the two most important goals: breaking apart their monolith into microservices and adopting a multi-cloud or hybrid cloud strategy. Let's take a quick look at the first goal. If we look at their monolithic application in more detail, we can see that they've got some distinct logical services already. In a monolithic application, these could be classes in an object-oriented language, but otherwise they're just portions of the code base with a distinct responsibility. And all this is hosted on that bare metal server that they own. Adopting a microservice approach would mean that rather than portions of the same code base, services are discrete and are only concerned with their own processes while still being able to communicate with other services. One of the primary benefits of this approach is that it allows services to scale and consume resources independently of one another. Now, let's discuss their next goal. A multi-cloud approach means utilizing services provided by multiple cloud providers. HashiCorp, one of the leading companies in the multi-cloud space, conducts a yearly survey to gain more insight into how companies are adopting multi-cloud. And according to their most recent State of the Cloud survey, 76% of respondents said that their companies have already adopted a multi-cloud strategy, with projections predicting this number reaching 86% in just 2 years. These are just a few reasons that companies are adopting a multi-cloud strategy. Avoiding single vendor lock-in. Companies don't want to be dependent on any one cloud provider. Another common issue is operational resiliency, ensuring that applications can remain online even if a service offered by one cloud provider goes offline. Security and governance can come into play, especially for companies who have to operate in certain localities that might not be covered by specific cloud providers. Emerging technologies can also play a part. A cloud provider that is the first to offer a tool in a specific field, such as artificial intelligence, is much more likely to be utilized by companies if they're already operating with that cloud provider. However, adopting this strategy can be difficult, especially for smaller companies. Some of the inhibitors that respondents brought up were lack of in-house skills. Small companies might not have dedicated DevOps teams to manage their infrastructure. Another is hybrid cloud complexity. Learning the ins and outs of just one cloud provider can be daunting, let alone multiple, especially since there's not a lot of exact one-to-one mappings of services. Tied in with that is the complexity of networking. And finally, absence of tools within the multi-cloud space. So now that we're familiar with ACME's digital transformation plans, let's see how the development team goes about implementing these changes. The first thing they're going to do is identify which service to extract out of the monolith. They want their users to be able to log in to third-party websites with their ACME accounts. However, this means that a lot of requests coming in just for authentication could degrade their overall application's performance. To solve this, they'll extract the auth service out of the monolith, and they'll want to deploy it where the service will be highly available. With that in mind, let's take a look at what the deployment pipeline could be with a multi-cloud approach. First, a software development team plans, architects, and develops an application. Go, Ruby, and Node.js are just a few languages that they could use. Then source code goes through some sort of build process to produce a runnable artifact. That could be containerizing the application to provide a slim, low footprint environment for the application to execute in using Docker. Or it could be compiling code from a front-end framework like React into static files using a package manager like Yarn. The artifact from the build phase is then used as the application is deployed to the proper hosting solution. There are many solutions out there, such as Google Cloud Run for container orchestration, AWS EC2 for virtual machines, and AWS S3 for static file hosting. Finally, any necessary resources for public consumption are configured to interface with an existing deployment, such as setting up an application load balancer to direct network traffic, or configuring a content distribution network like AWS CloudFront to distribute static files stored in S3. All this complexity can be difficult to both learn and manage, especially for a small development team with little DevOps experience. This is why platforms as a service have arisen. A platform as a service, or PaaS, abstracts away the complexity of the build, deploy, and release cycle. It allows developers to simply focus on their code. Examples of a PaaS are Heroku and cloud provider-specific platforms like Google's App Engine and Amazon's Elastic Beanstalk. And when you use a PaaS, you're generally trading control and configuration away for ease of use. So let's look at PaaS compared to other options like on-premise servers and infrastructure as a service. With on-premise servers, you have the most control and configurability of your environment, from your application all the way down to the bare metal server. However, with that comes a lot of responsibility. With physical servers come physical maintenance. Ensuring your server room is properly ventilated and secured is very important to ensuring your services are stable. Next, there's infrastructure as a service. As the name implies, the service you're paying for is the management and control of those physical servers. You no longer need the overhead of a server room and maintenance. Simply spin up a virtual machine and go from there. However, for simply deploying an application, there's still a lot of management and configuration overhead. And this is why platforms exist. Developers can concern themselves with their applications and data, while the platform handles the infrastructure under the hood. Let's revisit the Auth service ACME wants to deploy. They're allowing their users to log into third-party websites with their ACME accounts. However, they know it needs to be highly available since they can't predict the usage patterns of that third-party website. ACME has decided they want to use a PaaS for ease of use. They've decided on Google's App Engine, which will handle the build, deploy, and release cycle for their authentication service. Under the hood, Google uses their own Cloud Run container orchestrator, which is known to be highly available and scalable. But now ACME has another issue. As part of their payment logic, they process payment data, generate invoices, and store them on a local file server. However, their local file server is running out of disk space, and they don't want to keep buying hard drives. While they could use Google's cloud storage, they don't want to get locked into a single vendor so early on in their service extraction process. So they've decided to migrate their files to Amazon's S3. However, this also means they need to modify their payment service. They've decided to design a data pipeline. The application will send invoice data to an AWS Lambda, which will perform any pre-processing before sending it to Firehose, which will then stream it into their S3 buckets. As you can see, with just these two services extracted, the application topology is beginning to become more and more complex. They've got one service running on Google Cloud Run via App Engine, and their data pipeline on AWS. The development team at ACME is getting frustrated with the separated deployment pipelines and wish they could manage all of this in a unified platform. They've seen companies build their own platforms before and are toying with the idea themselves. Companies like Netflix and Atlassian have built their own platforms. The reasoning behind that is, as you initially set up infrastructure as a service offerings, you think that managing them will be as simple as setting up some load balancers, pointing them to an auto-scaling group of virtual machines, which then have access to your resources. However, the reality is that, especially as your application grows, this topology becomes increasingly complex to manage. It's difficult to track down exactly which application is running on which resource. Which deployments might be stale and ready to tear down, And overall, it takes a dedicated team to truly manage in an efficient manner. Both Netflix and Atlassian are large enterprises that can afford to dedicate teams to their platforms. ACME isn't. However, they're still interested in building their own platform. So let's take a look at what it takes to build your own PaaS. It could look like a lot of things. However, in today's environment, it most likely looks like this. Containerizing your application using Docker, along with maintaining a container registry. Managing your deployments with a container orchestrator like Kubernetes. This offers high availability and scalability of your container deployments. Plus, learning cloud provider specifics when it comes to networking, along with database provisioning and management with at least one database, such as Postgres. Maybe you want to trigger deploys on a pull request or enable Git polling, perhaps even integrate with GitHub Actions. Don't forget building your own user interface in your favorite front-end framework, such as React. All of this and more goes into building a platform like Heroku, and that's just for a single cloud provider. Because of this, ACME decided to shop around a bit more and stumbled upon Cloud 66, a multi-cloud PaaS. However, it has its own limitations, so let's compare it to their DIY solution. Cloud 66 does have many useful features, but it's currently limited to Node.js and Rails applications. However, it is easy to set up and it is cloud agnostic. The downside is that ACME would prefer an open source solution, and they would be paying platform fees on top of infrastructure fees. The other option, as we discussed, is building it themselves. This comes with its own learning curve and configuration headaches. Because of this, they might not have time to implement many features. It's not a very easy or simple process to get set up, but it is cloud agnostic and open source if they want it to be. And while they may not be paying platform fees, they're still spending precious development time on building out their platform. ACME is now wondering, is there a solution out there to easily set up an internal platform that can deploy to multiple cloud providers? And that is why we built Pilot, which is an open source multi-cloud framework that provisions an internal platform with a workflow-agnostic build, deploy, and release pipeline. So now that Pilot is in the picture, let's compare it to our other options. Pilot's not feature-rich. However, it has the necessary features ACME is looking for. It's also cloud agnostic and self-hosted. And it's also open source, so no extra fees. And since these concepts will be discussed throughout the remainder of the presentation, let's take one more look at the spectrum of ownership when it comes to platforms and focus on the difference between a PaaS and an internal PaaS. A PaaS manages everything for you, taking away control and configurability to provide ease of use. The platform provider, such as Heroku, manages the infrastructure themselves, potentially even using an infrastructure as a service provider. In Heroku's case, they build on top of AWS services. An internal or self-hosted PaaS still provides the ability to control and configure the platform as long as you have the expertise, while still providing sensible defaults so that novice users don't have to worry about the underlying services. In Pilot's case, developers can provision that internal PaaS on either Google Cloud or AWS. So the cloud provider still manages the underlying hardware, and Pilot manages the necessary infrastructure as a service offerings that we utilize, which we will discuss in the next section. As I've said, it's very straightforward to get Pilot up and running in your own cloud. I'll pass it along to my team member, Carl, to show just how easy it is.
All right, thanks, Ram. So I'll be going over Pilot's architecture and showing a demo of how a developer would set up Pilot and deploy an existing application to the cloud. Before we get into the demo, let's revisit ACME's desired architecture. They have their main application and a local server, and they want to deploy two services to different cloud providers, an authentication service on Google Cloud and a data pipeline service on AWS. What would it look like if they use Pilot to deploy these services? Now, let's assume that ACME already extracted both services into their own applications and are ready to deploy to AWS and Google Cloud. The first thing they need to do is provision the Pilot server. It's the core of Pilot, and it's what we'll be deploying our applications. Once that's done, all they have to do is call a single command, Pilot up, which will deploy a service into its desired cloud provider. The local Pilot CLI will send the command to the Pilot server, which then deploys a service. As you can see, the authentication service is now deployed to Google Cloud Run through a built-in plugin. Calling pilot up again, this time for the data pipeline service, we'll deploy the data preprocessor Lambda to AWS. So we're able to easily deploy to both AWS and Google Cloud Run, with the deployment process being the same. Now let's dive deeper into how the pilot server does this. But a quick recap, here's an example of how a PaaS can be built. And you can reference the image that Graham showed earlier. So you might containerize your application with Docker, orchestrate it with Kubernetes, ensure your network is robust within the desired cloud provider, provision and manage a database, integrate with GitHub, and finally build a UI to manage it all. If this seems like a lot, well, it is. We could have built Pilot using these tools, but much like ACME, we're a small team, and it would take a very long time to properly build a PaaS this way. Furthermore, our goal is to be able to deploy to multiple cloud providers, and doing it this way would augment that time frame even more. We need a tool that can help us expedite this process. So is there a tool out there to do that? Well, HashiCorp recently released Waypoint, a workflow-agnostic tool that can build, deploy, and release a variety of applications. It abstracts away the complexity of deploying to different cloud providers. However, there's still a lot of configuration needed in order to deploy an application, and we'll expand upon this later. Furthermore, it's simply just a tool for the deployment pipeline, not a replacement for a platform. So let's take a look under the hood and see what makes the pilot server. First, we provisioned a virtual machine. We chose AWS EC2 here, but it can be a Google Compute Engine instance as well. Then we installed Docker, which runs and manages our containers. And finally, we run our custom Waypoint server and runner. We had to build a custom Waypoint image so that the runner will have everything it needs to handle the deployment process. Vince will talk about this further in the engineering decisions section. Now, let's zoom in on how the pilot server deploys applications. The pilot server contains our custom Docker image that Waypoint uses to run both a server process and a runner agent. The server handles incoming requests, serves the UI, and caches the project metadata. When a user visits the app management UI, they're interacting with the server. The runner handles the deployment lifecycle execution. If we send the command pilot up to deploy our application, the server will first process the request, recognize that it's a deployment command, and tells the runner to deploy the application. Now that we know what the pilot server is made of, let's see how one might deploy one of their applications. So the app we're going to deploy today is a simple to-do list app, and it's where you can keep track of your to-dos. It's a full stack application that's connected to a database for storage. So instead of hosting it on our local server, what we're going to do is deploy it to Google Cloud Run. Now, there's two main steps we need to take in order to have our app deployed to Cloud Run. First, setting up the pilot server. This consists of the commands pilot init and pilot setup. And second is actually deploying the application. The command pilot new project, then linking the existing project through the pilot server UI, and the command pilot up will take us there. So first, setting up the local environment. To do that, we run pilot init. This command downloads the binaries we need, like Terraform and Waypoint, and also sets up the rest of our files for pilot to run properly. Once our local server is initialized, the next step is to provision our pilot server. To do that, we run the command pilot setup. This command provisions a virtual machine in the chosen cloud provider, in this case, an AWS EC2 instance. Although we could just as easily set up a compute engine instance in Google Cloud by calling pilot setup with the GCP flag instead of the AWS flag that you see here. This step normally takes a few minutes because it has a few things it needs to do, like provisioning a virtual machine, provisioning a database, installing all the necessary software for our remote server, and then configuring that server to work with our local environment. But once setup finishes, they're ready to deploy an application. It's important to note that it doesn't matter whether our server sits in an EC2 instance or a compute engine instance. We're still able to deploy to both Google Cloud and AWS. All we'll have to do is run the command pilot configure with either the AWS or GCP flag, which configures an IAM service account on the respective cloud provider for the pilot server to use. So at this point, we have a virtual machine configured with a PaaS, which is the pilot server, that can deploy new or existing applications to different cloud providers. Now that concludes the first phase, which is setting up the pilot server. We only have to perform this step once, and we'll be able to deploy to multiple apps from here. Now we're ready to move on to the next main step, which is deploying the application. Let's see what this process looks like. First, we need to create the project to deploy on the pilot server. It's as simple as calling pilot new project. This command will prompt us for the name of our project, in this case, pilot todos. And once we press enter, it will create the project in the pilot server and give us a hint on what to do next, which is creating the application. We can view the project through the UI by calling pilot UI, and it will look something like this. Let's zoom in a little bit here. If you look closely, you might have noticed that this is the app management UI that Waypoint provides us. We can create projects here as well and manage our current projects and their deployments. So now that we have a project created, we need to configure our existing application with it. This is a two-step process that consists of creating the app in our project and then linking our app repository to it. So first, creating the app. We run the command pilot new app. The command will prompt us for the necessary information it needs to set up the application. Here's where we configure general information about our app, like what cloud provider we're planning on deploying to, our application name, and various other information. But after that's configured, Pilot will generate a manifest file named Waypoint HCL, and that will need to push into our app repository. So that finishes step one of configuring our app. Now for step two, we'll need to configure our app settings through the Pilot UI. From our UI, we click on our project, then go to Manage Settings, and this brings up our project settings. We can link our application repository here by putting the Git source URL and other pertinent information like the Git source path, whether or not we're using authentication, and where the Waypoint HCL file is located. But once we hit apply, we'll have our application set up to be deployed. We can now deploy the app using the command pilot up. So we call that pilot up with the project name and app name as arguments. It will look at the Waypoint HCL file and go through the three phases of deployment: build, deploy, and release. So first, the build phase. The build phase lets Pilot know to build an image based off of the source code using cloud native build packs, and then push the image to the cloud container registry. Then the deploy phase lets Pilot know to configure Google Cloud Run resources. And finally, the release phase sets up the Cloud Run load balancer and readies the application for use. After the command finishes, the app is deployed and can be visited using the provided URL. Full deployment can sometimes take a few minutes, depending on where we're deploying to. But once it's fully deployed, we're able to visit the URL and see that our application is live. Now that we have a better understanding of the Pilot architecture, and we just saw how to deploy an app to the cloud using Pilot, let's quickly recap how ACME would deploy both the Auth service and the data pipeline service. So first, they initialize their local environment with Pilot init. Then they provision their Pilot server with Pilot setup, AWS. Since they're deploying to both AWS and Google Cloud, they need to configure G-Cloud credentials as well. They do this with Pilot configure GCP. And once the Pilot service provisioned, they can configure and deploy their application. At this point, they're also able to open the UI, where they can create and configure the app. They'll create the project in the CLI this time, though, using Pilot new project. They'll call the project Auth SVC. Then they create the app by calling Pilot new app. They'll simply call the app Auth. And we won't show it here for brevity's sake, but they also have to link the app repository through the UI. So after it's configured, they can deploy the application using Pilot up. It will go through the build, deploy, and release lifecycle. And after a few moments, the authentication service is deployed. Since the Pilot CLI and the Pilot server are already set up to deploy the data pipeline service, they can just start from creating a new project in the Pilot server and deploy with Pilot up. As you saw, ACME was able to easily deploy to multiple cloud providers. All they had to worry about was extracting each service into their own standalone applications, and Pilot did the rest. And by using Pilot, they own the cloud resources that their services are hosted on. I'll now hand off to Vince to talk about the engineering decisions and trade-offs we made, as well as the challenges that we faced while building Pilot.
Thanks, Carl. An integral decision for Pilot was to extend Waypoint. It's a fairly new product in the open source deployment space, but it did give us a solid foundation to work off of. We could focus on CLI and infrastructure development since Waypoint has an existing user interface. The Waypoint SDK allowed us to develop our own custom plugins in Go, which enabled us to add in static web hosting as a deployment option. It's also developed by HashiCorp, which we consider to be a trusted open source company with products that many other companies have incorporated into their multi-cloud strategies. Developers that have used HashiCorp's products are also familiar with their HashiCorp configuration language, as it is easy to read and write. Lastly, the design intentions of Waypoint really meshed with our own around Pilot. In using Waypoint ourselves, we liked the idea of collaboration, but found that aspect difficult to implement. If a team wanted to integrate Waypoint into their platform, this is what they would have to do. First, they would need to provision the necessary infrastructure, such as an AWS EC2 virtual machine to allow remote operations. Then install and configure dependencies, such as Waypoint and Docker at a minimum. They would have to set up networking and rules to allow their developers access to this remote Waypoint server. The Waypoint server would also need the proper permissions for all cloud providers that they want to deploy to. They'd probably also have to configure Docker and Docker for the Waypoint runner to handle building and pushing images. And finally, they would have to configure their local environment to communicate with the remote pipeline. So we believe this process could be more streamlined. We talked about our reasoning behind extending Waypoint and what the steps might look like to set up a remote Waypoint server. Next, we'll go into handling remote Waypoint operations and whether we chose Docker or Kubernetes for our server installation platform. And that brings us to one of our early design decisions. We decided to use a remote Waypoint server to serve as the backbone of our project. So why did we choose to create a remote Pilot server? In contrast, a simple Waypoint configuration is much easier when set up locally. In this diagram, we have the Waypoint binary and a server container running on a local machine. Here, a runner isn't necessary. The Waypoint binary will serve as a runner in this type of configuration. A remote Pilot server would enable us to provide increased flexibility for our users. The Pilot server can be provisioned on supported cloud providers to easily allow collaboration with a team. Users won't have to configure their local machine to be accessible on a network, and you get a centralized management server for project and application deployments. We also take away the concern of installing local dependencies for the deployment lifecycle. So there's no need to install Docker, Pack, or any additional tooling since it's already available on the Pilot server. But how should we install the Waypoint server to our virtual machine? Waypoint can install servers and runners using Docker, Kubernetes, and even HashiCorp's Nomad orchestration service. For us, the options came down to Docker and Kubernetes as an installation platform for our containers. With Kubernetes orchestration, we could spin up a cluster that would give us the benefits of high availability and scalability. Having multiple runners set up on a cluster would be able to handle concurrent deployments of applications. Cluster also has self-healing capabilities in case the containers were ever to go down. That all sounded great, but Kubernetes has some drawbacks. It introduces extra overhead for smaller development teams. It's difficult to understand and implement, especially if you want to get running quickly. And clusters can be difficult to manage without a dedicated DevOps person or team member with DevOps experience. With Pilot, we decided to have the Pilot server virtual machine provision a single server and runner container using Docker. Through our testing, a single Waypoint server and runner was enough for a small team. This makes it easier for users as they will only have to manage a single virtual machine with a couple of containers and not a Kubernetes cluster on top of it. Runners are considered an advanced configuration, but you could spin up more on the Pilot server if needed with documentation available on the Waypoint site. But now we move on to some implementation challenges of developing Pilot. Let's talk a little bit about plugins. Plugins are binaries written in Go that implement one or more Waypoint components. You can think of them as middleware for the deployment lifecycle. When we started learning about Waypoint, we realized that many of the built-in plugins were geared towards deploying full stack or back-end applications. We felt there was an opportunity for plugins that were able to deploy static assets. So we were happy to see Waypoint provides an SDK that allows developers to create their own plugins. You can create plugins that execute for the entire build, deploy, release cycle, or individual parts of it. For Pilot, we created several plugins. A Yarn plugin that executes during the build phase to bundle front-end applications into static files. an Amazon CloudFront plugin that interfaces during the deploy and release phases. This plugin will upload static files to S3 and release a static site to a CloudFront distribution. And finally, a Cloud CDN plugin for the GCP that works like the CloudFront plugin by uploading static files to cloud storage and releasing on Cloud CDN. Developing these plugins introduced their own challenges. For one, the documentation for creating plugins was a bit light on context. It focuses mainly on the build phase. The information for additional components is more conceptual. So we reference source code of the built-in plugins and custom plugins and trial and error to get the functionality that we wanted. Another problem was SDK support depending on the cloud provider. We found the AWS SDK to be robust and easy to work with. Anything we needed to provision for deploying to CloudFront could be done using it. The GCP SDK, however, was limited in some ways. Creating cloud storage buckets and uploading assets was supported, but provisioning the resources needed for a Cloud CDN release was not. Deleting certain resources from the SDK was also partially supported. We had to use a combination of the SDK with the gcloud CLI if we wanted the same functionality as the CloudFront plugin. We ended up creating a wrapper for gcloud commands to have similar usability as an SDK, and it worked out for our needs. This created a dependency on our Waypoint containers to have gcloud installed for deployments using our Cloud CDN plugin. So we went over some challenges of creating plugins, how SDK support came into play, and why we needed a GCP wrapper. We'll cap it off with our last challenge of building a custom image to handle Waypoint operations. So by default, Waypoint uses HashiCorp's Waypoint image, which can be found publicly available on Docker Hub. It includes the Waypoint binary and built-in plugins, but this introduced a problem for us. We wanted to include our custom plugins for Yarn builds and Cloud CDN and CloudFront deployments. Waypoint does not currently have a community plugin system for making custom plugins generally available. Our plugins are also had their own dependencies like Node.js and Yarn to build static files or gcloud CLI for Cloud CDN provisioning. In the end, we decided to create our own custom Waypoint development and release images that can be pulled from Docker Hub. To do this, we had to reverse engineer Waypoint's default image and source code to figure out how Waypoint starts the server and runner containers, but also what packages the Waypoint image had internally. We found it was pretty much a bare bones Linux distribution, and you were limited to the Bourne shell. This meant using HashiCorp's image as a base would require installing multiple standard Linux packages in our Docker file. Instead, we started off with a standard Node image and only needed to install gcloud as a dependency. This worked fine, but the resulting image was unnecessarily large. The Node image has other packages installed we really didn't need. So we discovered an image that Google maintains with gcloud and used it as a base for our custom image. This cut down the bloat by about 50%, which increased the performance of our Waypoint server installs using our image. We covered a bit of ground today and are coming to the last section of our presentation. Lastly is the future work portion. We'll wrap things up to a close. So there's many features we would like to add to Pilot, but we have a key few. We want to add support for a wider range of cloud providers, as we currently only support AWS and GCP. A user interface for database management, as this would provide central management rather than having users go through a cloud provider's management console. And we'd also like to make configuring environment variables of applications easier through a UI component. Currently, environment variables can be set within a Waypoint HCL file or using a Waypoint CLI on an application or project level. And lastly, we would like to support more infrastructure as a service offerings during our application initialization process. With AWS, for example, we default the generated configuration file to use Fargate deployments on ECS, but you could also use EC2 or Lambda deployments if you wished. So that concludes our presentation of Pilot, and here's our team. I'm glad you all could come out today, and we'll be sticking around a bit longer if you have any questions about Pilot.
Okay, we have 3 comments. Incredible job. That was awesome. An excellent presentation. We're going to wait a couple more minutes to see if we have any questions.
Thank you, everyone, for the awesome compliments.
Okay, we actually do have a question. And it's from Leah. She says, great job creating Pilot. What was your favorite part about building Pilot? Everyone can answer if they like.
Oh man,
'cause-
that's hard. I think I liked it because like we covered a lot of different things. So like not only did we work within Waypoint's ecosystem using Go and gRPC, but we also touched tools like Terraform and got to work with some interesting technologies there. So I just like the variety of tooling that we got to work with and integrate into our project.
Yeah, I want to double that, but also being able to provision like a cloud resource for the first time is pretty exciting, I thought.
Yeah, for me, it was definitely just looking into Waypoint's source code and just trying to figure out like how they were doing things and how we should go about doing things with our plugins, for example. So we just tried to kind of incorporate the same design decisions that they did with Waypoint. So that was actually really fun.
Okay, we have another question. How did you find this domain and decide to work on this project?
I can answer that one, I guess, because we stumbled upon this kind of domain by looking into containerization, specifically cloud native build packs, which we mentioned briefly, but essentially that allows you to containerize applications based just on source code. And when I read about those, I was actually inspired to create a much more, let's say, robust project. And it was just way too much to be able to implement in this amount of time. But it kind of directed us towards Waypoint. And once we discovered Waypoint, we realized it had a lot of the same kind of like design intentions that we were talking about. And that's kind of how we played around with it, and it just kind of evolved from there into, how are people using Waypoint? How can we use Waypoint, and just evolved from there.
Okay, we have another question from Ricardo. He says, excellent presentation, and any advantages of one cloud provider over a hybrid cloud or a hybrid cloud over one provider?
I can handle that one, or anyone else? Okay. Yeah, so it'll come down to your specific use case and whatnot. But generally, like with a single cloud provider, that's just less context switching. It comes down to just you only have to learn that ecosystem. And so that's why for small teams, it can be hard to adopt a multi-cloud approach. For multi-cloud, some of the reasons that we mentioned earlier, so like avoiding single vendor lock-in can be important. So we've heard stories of certain cloud providers trying to strong arm people into hiking up prices because their environments are so locked into their services. So single vendor lock-in was a big one for us. But ultimately it does just come down to your specific situation. But a lot of companies are shifting to it just to have a more modern approach and not let any one provider dominate the market.
And I'll just add to that, there's also the redundancy aspect of it, just because in case, like if you were on AWS and that was ever to go down for whatever reason, then you would still be able to spin up your services on GCP as an example, and while that would still be up.
I think we've got some questions in the chat, actually. So I can.
There are questions in the chat. Okay.
Yeah, I think starting with Malik.
Yeah. So the first question, what inspired the decision to target smaller dev teams and operations?
Yeah, it honestly came down to personal experience, at least for me. I was, on a small dev team a while ago. And so, yeah, there was just a lot of complexity when it came to cloud providers and whatnot. So some of it was from personal experience, but also just the three of us working together. We've worked throughout Launch School in various aspects, and so we there were a lot of pain points that we personally experienced as a small dev team with not a lot of DevOps experience. So it was a pretty personal decision for us, but it was validated by us, seeing other teams out there with the same pain points.
Okay, can you talk a little more about how a user configures Pilot as far as they need process entering their credentials for AWS JSP? Is there a config file involved along the way? And if so, what is the format of that like, and what does it contain?
I can take this one. So it's a prerequisite for Pilot if you're deploying to AWS or GCP. If you're deploying to AWS, you would have to install and configure your AWS CLI. So that's where you would get the credentials. It just grabs it from your local files and then passes it on into the Pilot server. That's the same with GCP and G-Cloud.
Okay, we have more questions. Having gone through the exploration and context gaining phase, are there any pieces or parts of your infrastructure that you would like to extend or modularize or replace with other technologies that you became aware of? Also, who did your branding?
Well, for branding, another Launch School student, Karis, I forgot her last name, but she did the logo and like color palettes and stuff. As far as the presentation, that was me. I did all of the presentation branding, but the branding is all based on the designs that she gave us. And what was the other, the actual question? Let me pull it up real quick. Let's see. Okay, yeah. So the exploration and context gaining phase, any pieces or parts of infrastructure that we would like to extend or modularize or replace with other technologies. For me, I would say yes and no. Like there are definitely certain benefits that we talked about, like with container orchestration, like Kubernetes. So I think that of anything, transforming the Pilot server into a Kubernetes cluster would be the biggest boon if we could figure out a way to still have it be manageable for users. Because I think that would just be the biggest return on investment as far as performance and dynamically spinning up runners for deployments and all of that. So I think that was probably the biggest thing for me that I think we could improve upon. Yeah. I don't know about Vince or Carl though, but.
Okay, we have final question, and it is: what was the most challenging piece of technology you work with besides Waypoint? It sounded like you work with a lot of new tools like Terraform.
Yeah, I can start this one. Terraform was actually pretty fun to work with. The documentation is pretty robust, and it's widely used. So there's a lot of people out there with articles and problems that they solve already. But as far as working with Terraform, a challenge that we encountered was using this tool called Cloud Init and just basically provisioning or bootstrapping the server with the software that we needed. We had a lot of manual processing at first, and then we figured out that we can do it with Cloud Init, so that made it a lot easier for us.
And then I think for me, it was working with some aspects of Docker. We didn't get into it here, but we'll get into it in our write-up, just kind of the challenges of running Docker from another container and how to just go about doing that properly without it also being a security flaw in someone's infrastructure. But yeah, that was a fun one.
Yeah, and for me, I agree with both of those, but I think the difficult and probably most fun challenge was just the plugin development. So kind of like having to conform like to someone else's design decisions, is a very important thing when working with a tool. And so like not having a lot of flexibility there was a challenge. So like if we were to work within Waypoint's ecosystem, we had to use Go and their SDK. And so that was a challenge, but it was also very interesting and unique challenge of learning about things like gRPC and how Waypoint internally works. So it was very, very interesting. Yeah.
Okay, awesome work once again. We don't have any further questions, so any final thoughts?
I'd just like to thank everyone for coming out and being supportive and asking a lot of really good questions. We'll be on the Launch School Slack for those of you there and be able to answer even more questions if y'all want.